Okay, now we've had a look at the addition rule. I'm going to try and make this really quick on conditional probability. Conditional probability is when we are given something. So, for example, what is the probability is if we were to ask you if we've got M is for students who who choose maths and students who choose biology. Now, you can choose maths and biology at the same time. You can see there that 13 students have chosen maths or biology. How many students have not chosen maths or biology? In other words, we've got B complement intersect with M complement. Okay? So, no. We've got not B, and B or not M. Well, that is equal to 34 students. Now, that's the number of students. We tend to ask for probabilities. So this can be written as if we would like to know the probability that you are doing maths given that you're doing biology, we write it like this. So what is the probability of doing maths given that you are doing biology? Well, first of all, we have to really look at only this set. So let's think about how many favourable outcomes. The probability of M given B is equal to the number of favourable outcomes, which is basically this intersection here, or 13, and this time it's out of the probability of B, which is, there's 29 if you like. Now this isn't the probability, but you've got the probability is, I guess in this case, a fraction. 13 out of 29 students are doing maths given that they're doing biology. So this is what we call conditional probability, and it's written such as the probability of maths given biology. Okay, and we've got to remember this rule. This is the conditional probability rule. Okay, so it's definitely something that you'll have in your bound reference. Now let's have a look at an example. I've got the formula in the top right hand corner. The event A is the event of selecting an ace from a pack of cards. Well, what is the probability of an ace? The probability of an ace from a pack of cards is equal to 4 out of 52, and as we discussed in the last video, that is equal to 1 out of 13. What is the probability that the card is black? Well, we've got red cards and we've got black cards. Half of them are red, half of them are black. So the probability that a card is black is actually equal to 26 out of 52, or a half. Now we can draw a Venn diagram to do the situation. So let's do it, and you might want to pause the video and have a go yourself at this question. So I'll get you to pause it now and have a go at this question using this rule up here. Okay, so let's go ahead and do this together. I hope you've actually had a go. I'm going to draw my Venn diagram, and first of all, let's just assume that the A and B, there is some intersection. Well, there is, because there's black cards, which is an ace. And I want you to think about how many black cards are aces. You've got the ace of spades, and you've also got the ace of clubs. So there is going to be an intersection. In other words, then these two events are not mutually exclusive. So let's have a look, and we're going to call A for ace and B for black. We've got A for ace, B for black. Let's think about, so we've drawn a Venn diagram for the situation. Now we've got to fill it in with some details. How many aces are there? Well, there's 4 aces, and we're not going to deal with probabilities. We're going to talk about the number. So what's the number of A? What's the number of events B? What's the number of events A intersection B? And we can deal with probabilities later, but just by doing fractions, because we know that there's 52 possible outcomes. So ace, there is 4 aces in the deck. Okay, however, 2 of those are not black. So A intersection not B, if you like, is equal to the number of A intersection B is equal to 2. That's what this represents. Now, what about B? How many cards are black, but they're not aces? Well, there's 26 blacks. Take out 2, there is 24. And therefore, there's also these 2 in here, which because we know that we have 4 aces and we know we have 26. You can see there that this adds to 26, and we can see that this adds to 4. So we've now drawn a Venn diagram for the situation. However, how many cards are not black or not aces? Well, we've got 26 plus 2, 28. So there are 24 cards in the deck which are not black or not aces. So we need to make sure that we account for that. A lot of students just sort of forget this, okay? The total number in the whole set, okay? The total number is equal to 52 in total. It has to add up to 52. 48 plus 4 is 52. Now we want to find the probability using this formula over here, the probability of A given B. Well, given that we've got B, the probability of A given B, just looking at a Venn diagram, you don't need this formula. The probability of A, which is this thing here, given that it's B, is 2 out of 26, or 1 out of 13. What about the other way? What's the probability of B given A? Well, given that we've got A, we've got 2 aces. What's the probability of getting a black card if we know that we've got an ace? Well, we know that logically we've got 26. Sorry, I'm going to repeat myself. Probability of B given A. Okay, there are 2 black cards out of 4 aces. So the probability of B given A is equal to half, which would sort of make sense. Now you can use this formula, but if you've drawn a Venn diagram, you don't need to use that formula. It really is basically just sort of explaining that. So having a Venn diagram is really important. Now let's have a look and start looking at what's called a Carnot map. From a group of 15 hockey players, so let's think about this, 15 hockey players. That's a really important thing because we've got 15 and we're going to deal with numbers and not probabilities here. Okay, but they must add to 15. All of this over here has to add to 15, which means that this row here has to add to 15, and so does this. So let's have a look. 13 played on the field, 7 sat on the bench, and 5 both played and sat on the bench. So we're going to call A on the field. Okay, we're going to call A on the field, which means that this whole column has to add to what? Has to add to, I want you to pause the video and I want you to think about it. Okay, so hopefully you've had a bit of a think about it. What is the probability of, given that A is on the field and B is on the bench, okay, then the probability of on the field, there's 13 people who are on the field. Okay, now if there's 13 people who are on the field and this has to add to 15, then that means that there's 2 people that were not on the field. Okay, so we're starting to fill this out. What about the people that sat on the bench? 7 sat on the bench. A total of 7 sat on the bench. That means that 8 did not sit on the bench. And you can see here by filling this out that the total has to add up to 15. 7 plus 8 is 15, 13 plus 2 is 15. Now let's sort of think about it. 13 played on the field. Now it says here, and 7 sat on the bench. Is there anything you can do to fill out the rest of this table? I'll get you to think about it. 5 both played and sat on the bench. Okay, so let's think about where that would go.
Mr. Harris, can you come to reception, please, Mr. Harris? Thank you.
Think about where that would go on this Venn diagram. I'm going to pause the video now. Alright, so if you played, you could satisfy A. If you think about it, A intersection B means that you played and both sat on the bench. So that means that this is 5. Wow, look at that. Just by having that piece of information, we can now fill it out because this column here, it has to add to 13. So what does that make that? That means that 8 people played and didn't sit on the bench. And then we look at this. If 5 people played and sat on the bench, but 7 people didn't play at all, okay, or sorry, 7 people sat on the bench, then that means that 2 people, they sat on the bench, but they also didn't play. Okay, so these 2 people, really lucked out, didn't they? Okay, these two people, they didn't get a game, basically. Now, let's think about it. What about not B, which means that they didn't sit on the bench, but they didn't play? Well, what did that mean? These are the people that, it's a bit confusing. Well, 8, look at that. All of them played. Okay, so 8 plus 0 is 8, 2 plus 2. Okay, you're probably asking yourself, what the hell was that one? Well, I guess, no, we're talking about 15 players that played. So the probability of not A and not B is equal to 0. It just can't happen. So we've drawn a two-way table. We've found the probability. Find the probability of the person that's the person only sat on the bench. The person that only sat on the bench is this guy over here. So that's 2 out of 15. The probability of the person that sat on the bench given that they played on the field. Well, this is this whole probability of that they sat on the bench. Sat on the bench. Now, what's the probability that they sat on the bench? Well, that is equal to the people that are B, which is 7 out of 15. All right, so 7 out of 15 is the probability that they sat on the bench, given, though, that they played on the field. If they played on the field, that's 13 out of 15. Now, I'd like you to use this formula over here, and I've explained that formula, so you should be able to work it out. Now, find the probability the person played on the field, given that they sat on the bench. Well, that is the probability. So let's have a look at this. I'm going to pause the video now, and I'd like you to have a go at it, and I'll reveal my solution in a moment. Okay, so I've got to get to class now. So I've just written my solutions there. You can finish it off. If you've done this using the conditional probability rule, and then you can simplify this fraction in your calculator, but as it turns out, we're going to get an answer of 5 out of 7 as a fraction for this one, and for this one, we're going to get 5 over 13 divided by, or times by, 15 over 13 is equal to whatever that gives, okay? So 25 over 169. So there you go. I'm going to leave you to it. Yeah, hopefully you learned something about conditional probability today.